Graphing quadratic functions, 9.1. Graphing quadratics. To graph a quadratic function, you need the vertex, the axis of symmetry, and 2 additional points. Graphing a quadratic function. Find the vertex. To find the vertex, x will equal negative b over 2a. In the y, you will substitute the value that you find for x into the equation and solve. You find the axis of symmetry with the equation x equals negative b over 2a. Find an additional point on the parabola. Try to use c, the y-intercept. If you cannot use c, then pick a number for x, plug it in, and get y. Reflect point in 3 over the axis of symmetry. Okay. So it says graph y equals x squared plus 3. Determine the domain and range. So first I will label my a, which is 1, my b, which is 0, there's no x, and my c, which is 3. Okay, first we want to find our axis of symmetry, and we find that by doing x equals negative b over 2a. So, negative 0 over 2 times 1. So, my x will equal 0. So, x equals 0 is my axis of symmetry. Now I'm going to take that value and substitute it into my original equation to find my vertex. So my vertex is at 0, 3. Now I need to find an additional point because 3 is my y-intercept, so I can't use it, or I already am using it. So I want to pick a point near my axis of symmetry. So I'm going to pick the point 1. So x equals 1, or when x equals 1, we're going to find what y is going to be. Y is 1 squared plus 3. So that is 4. So our additional point would be 1, 4. So now it's time to graph. So my axis of symmetry is at 0. My vertex is at 0, 3. And my additional point is at 1, 4. And I can mirror this additional point over my axis of symmetry. So that is how you would graph. Now we need to find the domain and range. So the domain is the values for x. So as my graph continues to grow, it's going to eventually hit all the x values. It's going to hit all of the x values. So my domain is all real numbers. My range is where my y values. So am I going to have negative 1? No. Am I going to have 1? No. 2? No. 3 is a value. So my y has to be greater than or equal than 2, 3, because it will be everything above 3. Okay, let's try another one. So first I'm going to label my A, B, and C. A equals -2, B equals -4, and C equals 0, because there's not a value at the end. So let's find our axis of symmetry. So that is x equals -b over 2a. So -4 over 2 times -2. So that will give me 4 over -4. So -1. So my axis of symmetry is x equals -1. So let's find our vertex. I'm going to substitute -1 into my equation. So y will equal -2, parentheses, -1 squared, minus 4 times -1. So 1 squared is 1, or -1 squared is 1. And -4 times -1 is +4. And this will give me -2 plus 4. So my y will equal 2. So my vertex is at -1, 2. So is my vertex my y-intercept? No. So my additional point can be my vertex. Or my vertex, my y-intercept. So let's draw our graph. Okay, so my axis of symmetry is at -1. My vertex is at -1, 2. And my additional point is 0. So that is 2 below, 1 over, so 2 below, 1 over. Near that point over, and we graph it. So our domain. So as my graph continues to grow, it is going to eventually hit all x values. So my domain is all real numbers. However, my range, my y values, I will never have anything above 2. So it has to be y has to be less than or equal to 2. Okay, let's try another one. So let's label our A, B, and C. So A equals -1/2, B equals 2, and C equals -1. So our axis of symmetry is x equals -b over 2 times A. So that will be -2 over 2 times -1/2. That would be -2 over 1, -1, which will equal 2. So our axis of symmetry is x equals 2. So let's plug that into our equation to find our vertex. So y will equal -1/2 times 2 squared plus 2 times 2 minus 1. So 2 squared is 4. -1/2 times 4 is -2. So our y will equal 2. Our y will equal 1. So, our additional point. Did I use my -1? Nope. So I can use my -1 as my additional point. Okay, let's graph this. So, my axis of symmetry is at 2. My vertex is at 2, 1. My y-intercept is -1, so that's 1, 2 over, so I'll go 2 over 1, 1, 2, and down 1. Okay. And that is how we graph this parabola. So now we just have to determine the domain and range. So our domain, again, as our x, or as our graph continues, it will eventually hit every single x value. So our range is all real numbers. However, our graph will never go above 1. So our range is y is less than or equal to 1. Okay, one more to go. Okay, so let's identify our A, B, and C. So A is 3, B is 9, and C is 4. Okay, now let's find our axis of symmetry. Remember, axis of symmetry is x equals -b over 2a. So, -9 over 2 times 3. So, that will be -3 over 2. -9 over 6 equals -3 over 2. So I'm going to substitute -3 over 2 into our equation. So x equals -3 over 2, or we can say that it's -1.5. So our vertex, we will have y equals 3 times -1.5 squared plus 9 times -1.5 plus 4. So our y will equal -2.75. So our vertex is -1.5 and -2.75. So our additional point, we didn't use our C yet, so I can use my C, which is my y-intercept. So now let's graph. Okay, so our axis of symmetry is at negative 1.5. So negative 1.5. So halfway in between 1 and 2. We need to label this. Axis of symmetry. X equals negative 1.5. Okay, my vertex is at negative 1.5 and negative 2.75. So about here. And my additional point is at 4. So then that is 1.5 over, so half 1 and then up to the 4, mirror that over. And this is a narrow graph. And there you go. So now we just have to determine our domain. You guessed it, all real numbers. And our range is y is greater than or equal to negative 2.75. Okay. So that is how you graph parabolas. You will have multiple questions on your test on graphing parabolas in standard form. 5 questions total.